Let's try to identify the polar form of the complex number z sub 4 is equal to minus 2i. Again, our complex number here is minus 2i. Now, to determine the polar form, we really need to identify the following, because we could write this in this manner: r times cosine theta. You have here plus I sine theta. Okay, so our r is identified as the modulus of our complex number. Now, our theta will be dependent on the location of our complex number on this Cartesian plane, or in this Argand diagram rather, Argand diagram, okay, which is diagram for complex numbers. So in order for us to locate our what they call this one, our point on the Argand diagram here, we need to identify the x and y components. Our x component is actually the coefficient of the real part of our complex number, and since there's no real part here, we will have here 0. As for our y, it's the coefficient of our imaginary part, which is minus 2. So the location of our point is actually here. You have here 0, 1, and then 2. This is the location, sorry for that, of our point in this Argand diagram here, or let me change the color, this one here. As you can see, it is on the axis itself. Okay, that would mean that if we're going to look for the angle later on of theta of this, it's actually the location of that point. Now, there are two different ways that you can do this, and one here, and of course both of these angles represent the same thing. It could be the angle that is formed counterclockwise, meaning positive towards that, or the negative angle that is actually formed in this manner. So I don't know if which would you prefer. Now, for some references, they would prefer the negative because it's even smaller than the positive. Let's present them or represent them, of course, later on as well. But to start, let's try to identify the length or the modulus of our given identified complex number. Of course, it's very obvious here if we're going to look at the modulus of that. But of course, by the formula itself, let's try to illustrate it as well. It's actually the modulus of z sub 4, or the modulus of the entire form, minus 2i, which corresponds to the square root of the sum of the squares of the coefficients. Since there's no x, we have 0 squared plus negative 2 squared. You will get here the square root of 0 plus 4 square root of 4, or you will get here 2. This is the modulus or the length of our r here. In this case, we can now substitute that in this manner. Okay, so that's okay for that. However, as mentioned, we are still going to find out what would be our theta. Our theta could be in radian measurement. Generally, if our angle is a special type of angle, we can stick with the radian measurement. Just like this one, since it's on the axis, then we can use a special angle. Now, for some cases where there's no specific special angle, we can use the approximation in terms of degrees. But the thing that is similar for all is once we could come up with a triangle, because for some location, just say for example, if it's located here, you can come up with a triangle and you can use the trigonometric ratio sine, tangent, or cosine to solve for the angle. So you can use that. But this time, since again it's on an axis, we can simply determine the angle that is formed. Okay, now for the red one, the red motion, the positive, it's actually 3 pi over 2. Okay, but for the white one, the negative movement, it's actually, sorry, not 3 pi over 4, my bad. It's 3 pi over 2 because it's on the negative y-axis. So 3 pi over 2. But for the white one, it's just simply negative pi halves. Now, for some references, both two things are actually considered. And this time, let's show both of them. But this 2 corresponds for the angle intended for the polar form. So, for that, we can now form for our final. Okay? So, again, this is actually minus 2i. So, we can actually form it in this manner. You will have here 2 as your r. And times, you have your cosine. For the red one, you have 3 pi over 2 plus I sine 3 pi over 2. That is already okay. But for some instances, they also use another form. Let's say, for example, using the pi halves. So you can also form it like z sub 4 is twice. You have your cosine, but it's negative pi halves plus I, so let's put it at the bottom, plus I sine of negative pi halves. Okay, both of them are actually acceptable, but some references would not use this because it's negative. But some references also would use that because it's simpler and it's smaller than 3 pi over 2. But let's stick to this because we would like, if a possible, positive um, angles. Now, there are also other way to writing this. We have here r cis theta. So we have here our z sub 4 can be written as 2 cis and then 3 pi over 2. Or again, in this case, you will have 2 cis negative pi over 2. They mean the same thing as well. This is the polar form of the complex number. Again, it's shorter than the previous ones because we're able to establish that it's already on the axis and we're able to identify the angle as easy as it is. Thank you very much for watching.